Hello, welcome to Unit 3 of the Advanced Java course. In this unit we will dive deeper into the fundamentals of object-oriented programming. In this unit we'll be going over inheritance, abstract classes, and interfaces. So let's start. While you might already have learned about inheritance at the beginner's Java course, we're going to go into a little bit more detail in this chapter. So the idea of inheritance is very simple, but it's also very powerful. Inheritance defines a relationship between objects that share, the same characteristics. So when you want to create a class, and there's already another class that includes some of the code you want, then you can just make a new class that's subservient to that existing class. So in doing this, you can reuse the fields, the methods of the existing class without having to write them yourself all over again. So inheritance is a mechanism where a new class, a subclass, is created from an existing class, which we call the superclass. We say that a subclass inherits characteristics from this superclass. So, while the names might be a bit confusing, a subclass is actually quite bigger than a superclass, mainly because a subclass will contain the same methods and the same fields as the original superclass, but it will have its own specific set of methods along with it that's inherited from it. So don't let the names confuse you. So, a class can only inherit from one superclass, but it can have many subclasses. So, which forms an inheritance of an inheritance hierarchy. So you can represent an inheritance hierarchy with something like a diagram, like a pedigree, which looks like something like this. So a class can inherit from another class by using the extends keyword. So here I've declared car, and it extends the class of transportation. So I'll get to that a little bit soon. So there's many types of transportation, but we use transportation as the general form of transportation. So there's many forms of it, like a car, a boat, or an airplane. They all have something in common. They move people, they travel, and they have a speed associated with it, correct? Yet they all are unique and have some defining characteristics. For example, the dimension of height is critical for an airplane because it'll affect how it travels and whatnot. But for something that isn't an airplane, like a car or a boat, you don't really need to involve height. So in this case, the subclasses are sort of mutually exclusive in this regard when it comes to unique characteristics. So using inheritance, you can start off with all the common properties and then branch out into all the unique characteristics. So you can reuse and recycle code, which is very efficient for programmers. So the class car here and airplane are derived from the transportation superclass. So you just remember, subclasses are mutually exclusive. They're not really related to each other in any way other than the common code they share. So car does not inherit anything from airplane. So as you can see, the classes car and airplane inherit transportation with the extends keyword. And they also, with that being said, they also inherit the methods associated with it. So they both inherit the change speed method right here. So, however, keep in mind that the constructors are never inherited. This is never inherited. But most of the time, a subclass is very similar to a superclass. So here we can use the super keyword to inherit the constructor that's used for this, and then translate it onto the car method, the car constructor, sorry. So similarly for an airplane, they will also use the super method, using the same variables associated with it. So remember, if a super is used in an implementation of a subclass, it must be used in the first line because you have to construct it. All of this information about classes in mind, it's important to know how to declare it because that's the essence of object-oriented programming. So what I'm about to show you is how you can legally declare these classes together. So I will start with a superclass. So with a superclass, you can declare a superclass, and you can refer to any of the subclasses because transportation in this case, which I declared here, is the most generic of them. So this A So this is a legal declaration. I only put the 0 here because they require an argument here. But as you can see, this is self-explanatory. This is how you normally declare an object. This is also legal. Again, this is the generic class referring to its subclass. And I'll demonstrate that one more time, but a little twist onto it. Okay. Here I put my second 0 because the new constructor for airplane requires 2 arguments. So I just put that there. So as you can see, all of these are legal. However, keep in mind, you cannot go the opposite way. You can't go from a subclass to a superclass because they don't contain the same information. So, I'll put an example here. This is undefined. This is a type mismatch. You can't convert from transportation to car. And that makes sense because not all cars are a form of transportation, but transportation, forms of transportations are always going to be a car. If that makes sense to you. So in general, you should follow this format. And this format in general will work. You can also declare the same superclass like normal. So let's move on to polymorphism. A method that has been overridden and at least one subclass, which I've put here, airplane, this change speed has been overridden. If it's said to be overridden in at least one subclass, it's said to be polymorphic. Now what polymorphic means is, I'll show you here, polymorphic is that it inherits the same name, but it has a different implementation in the method, in this particular subclass. So you might wonder what would happen if I decided to do this. Now I'm just putting these here just for show. I'll fix the new speed part, but you might wonder what method it will run from because now I've introduced this into the twist. So polymorphism is a mechanism of selecting which appropriate method for a particular object in the class hierarchy. So the correct method is always chosen because in Java methods are always determined by the actual object, not by the object reference. So for an example, the airplane, because C is declared to be airplane, it will use the airplane method because I declared it to be an airplane and not a transportation. In these two, it'll always do the same thing because I haven't changed anything from car. So even though this is a car, it will refer to the original change speed, and obviously the first one will also do the same thing. So even though A, B, and C are declared to be transportation, the method calls will all perform the same operations for their particular class. So, well, that's it for inheritance and polymorphism.